Hi friends, this is Syed Reshma Sharif. In this video lecture today I am going to give explanation about waveguides and resonators, that is in microwave engineering. First of all, introduction. Microwaves. Microwaves are same as electromagnetic waves. Microwaves are electromagnetic waves. Okay, whose range is from 1 gigahertz to 1000 gigahertz. Microwaves are electromagnetic waves and their frequency ranges from 1 gigahertz to 1000 gigahertz. For comparison, the signal from an AM radio station, AM here nothing but amplitude modulation. Okay, AM radio station that is of 1 megahertz and signal from FM. FM is nothing but frequency modulation. Radio station is of 100 megahertz. Okay, signal from AM radio station is 1 megahertz and signal from frequency modulation radio station is 100 megahertz. Microwaves are so called since they are defined in terms of their wavelengths. Based upon their wavelengths only, isn't it? How their waves are, we are going to refer. Micro means very small. It means very small. Micro means. The micro refers to tininess. Tininess is nothing but very small. Tininess referring to a wavelength and period of a cycle of centimeter wave. Okay, of centimeter wave. Per one centimeter, how many number of cycles they are moving? Okay, per centimeter. The period of cycle that is defined completely by microwaves. Okay. In other words, the wavelength lambda is a wavelength of centimeter waves. CM waves are nothing but centimeter waves. Yet microwave frequencies are very short, typically from few tens of centimeters to a fraction of a millimeters. Okay, few tens of centimeters to a fraction of millimeter. It means microwaves are very fraction of seconds. They are the wavelength of centimeter waves for one wavelength. Okay, 1 centimeter. In short, a microwave is a signal that has wavelength of 1 foot or less. That is, wavelength lambda is less than 30.5 centimeters. 30.5 centimeters is similar nothing but 1 foot. Okay, lambda is equal to C by F. Whereas to find frequency, here F is equal to C by lambda. Okay, here C is nothing but 3 into 10 power of 8. Okay, by 30 centimeters they given. Now we are converting this one into meters. What we will get 30.5 into 10 square. Okay, that equal to 984 megahertz. That is equal to 984 is nearly to 1000, isn't it? So we are writing 1 gigahertz. Okay. Here C is nothing but a speed of light in vacuum. By lambda is nothing but wavelength. We will get 1 gigahertz its frequency. So all frequencies above approximately 1000 megahertz is equal to 1 gigahertz. To about 1000 gigahertz are microwave frequencies. All frequencies which are above 1000 gigahertz, that is 1000 megahertz to about 1000 gigahertz, are called as microwave frequencies. Okay, so here this is of a microwave frequency or not? Yes, it is a microwave frequency. It is of 1 gigahertz. The higher frequency edges of microwave borders on infrared and visible light regions or spectrum. Okay, the higher frequency edges of microwave borders are on infrared rays and visible light regions or spectrum. Microwave frequencies are classified separately from light region, separately from radio waves. Okay, here these are microwave frequencies are classified separately from radio waves. Okay, radio waves are not same as microwaves. Okay, microwaves are little different. shows the various availability of electromagnetic frequency spectrum. Let us discuss this one. Okay, these are our microwave band L, S, C, X, K, U, K, K, A. Okay, L band, that is of frequency 1 gigahertz. Here 1 gigahertz, 2 gigahertz, and S band frequencies of 2 gigahertz to 4 gigahertz, and C band, X band. Here the frequencies of 8 gigahertz. This is of 12 gigahertz to 18 gigahertz, that is Ku frequency band, and 18 gigahertz to 27 gigahertz, that is of K band. Here 27 gigahertz to 40 gigahertz, that is of Ka band. Whereas here 40 gigahertz to here, that is millimeter, and here sub millimeter. Okay, 0.300 terahertz. Okay, here this one all are of ELF, SLF, VLF, LF, MF, HF, VHF, UHF. All are those bands. SHF, EHF, infrared, light, X-rays, gamma rays, cosmic rays, etc. Here the full form of these frequencies are ELF, means extreme low frequencies. Okay, extreme low frequency. Here extreme low frequency, that is of 300 hertz. Here 30 hertz to 300 hertz. SLF means super low frequency. Okay. SLF, VLF means very low frequency, LF means low frequency, MF means medium frequency, HF means high frequency, VHF means very high frequency, UHF means ultra high frequency, SHF means super high frequency, EHF means extremely high frequency, infrared, light, X-rays, gamma rays, cosmic rays. All those rays cannot be visible to our naked eye. Okay, only some X-rays and we can't see, isn't it? X-rays and all we will experience in hospitals, etc. But we can't see all those X-rays. They have the capability to penetrate into any region. Okay, the visible light is above infrared region and falls between 430 megahertz to 1 pHz. This region includes the fiber optics laser region. This is region above 1 pHz, includes X-rays, gamma rays and cosmic rays. These cannot be visible to our naked eye. The various metric prefix such as mega, micro are given in table. This is a preferred table where all our frequencies given in power of 10. Okay, power of 10 symbol. Extra frequency means power of 10 power of 18 symbol. We have to learn all those table, isn't it? We have to learn all these table. Here beta means 10 power of 15. Extra means in the power of 10 means we have to remember 10 power of 18. Like that we will remember. Symbol is E. Beta means 10 power of 15. Symbol is P. Tera means 10 power of 12. Symbol is T. Prefix means power of 10. Symbol is its symbol. Prefix power of 10 here. See, this is a symbol. Now here we are giving giga 10 power of 9. Here G is a symbol. Whereas mega 10 power of 6 M. Symbol is M. Kilo means 10 power of 3 K. Milli means 10 power of minus 3 M. Micro means 10 power of minus 6 mu. M, small m. Okay. Nano. Okay, no, sorry. Micro means this one. Mu. This can be called as a mu. Okay, nano means n. It is a 10 power of minus 9. Pico means 10 power of minus 12 p. Femto means 10 power of minus 15 f. Atto means 10 power of minus 18 a. These all table we have to remember. Carefully we have to learn all those. Okay, all the symbols and their prefix as well as the power of 10 values. Microwave region and band designations. Now, till now, what we will learn, what are all the frequencies, symbols, how all those been in their ranges. Now we are going to discuss about microwave region and band designations. Microwave region is the electromagnetic spectrum is shown in table 1. Here the CCIR here microwave region is electromagnetic spectrum. It is shown in table 1 along this frequency. As per CCIR, here nothing but Consultative Committee for International Radio. What is the full form of this one? Consultative Committee. Consultative Committee for International Radio. You have to remember what is the full form of this one. Consultative Committee for International Radio. These recommendations, it may be noted that beginning of each band is multiple of 10 of previous bands or the next bands. Okay. What is this refers to? Here in this table, see here the multiples of for each and every frequencies. It is of multiple or doubles the band. Okay, here 300, here 3 kHz, here 30, here 300. Okay, it means multiples for every band of frequencies. It has been multiplied. Here see 1 gigahertz, 2 gigahertz. Here 2 to 4. Here 4, 8, 8, 6, 8, 12. Here 18. Okay. Here multiples of 2. 1, 2 square, 4, 4 square, 8, 8 square, 8. Here are 2. Here 4. Again we are going to add till here. Here 12. Here again 4 we are adding. Like see multiples like that we are getting. Standard band designations for microwave listed as per Institute of Electromechanical Electronic Engineering. Institute of Electrical and Electronic Engineering is the industry standard. This is shown in our next. Let us see. Here band designations given as band designations, frequencies in hertz, applications. Here extremely low frequency ELF, that is 30 to 300 hertz. In these what we will get communication with submarines. This is mostly used underwater. It means these extremely low frequencies has the capability to penetrate into the water. Penetrate into water. Voice frequencies 300 to 3000 hertz. Telephone, baseband applications, etc. Telephone in our daily lives, I think everyone know about telephone, isn't it? Here this frequency we are going to use for these voice frequencies, that is 30 to 3000 hertz. Here next one is very low frequencies 3 to 30 kilohertz. These are used in long distance point to point communications. Very rarely used, while I think these are used in sending messages from one destination to other destinations, while most these are used in military appliances, etc. Next one, low frequencies. Low frequencies are of about 30 to 300 kilohertz. These are used in point to point marine communications, time standard and frequency broadcast. Marine communication means they have the capability and point to point from one point to another point. Okay, it must have known low frequencies, isn't it? It must be known a designation. Okay, at the time it can use for point to point communication at marine. Medium frequencies 300 to 3000 kilohertz. These are used in broadcasting and marine communications. Okay, high frequencies 3 to 30 megahertz. These are used in moderate and long distance communication in all types. For example, aeroplanes. Okay, planes, and all we can use this mode of communication. High frequencies, very high frequencies, these are used in television, FM service, navigation, and police. Okay, ultra high frequencies, these are of 300 to 3000 megahertz, that is 3 gigahertz. These are used in short distance communication including radars. Radars means radio detection and its ranging. It ranging when ultra high frequencies are used at short distance communication, including radar. Whenever the distance is very less, at the time these ultra high frequencies are used. We can find radars also. Super high frequency, that is 3 to 30 gigahertz. These are used in radar, microwaves, and space communication. Very, very important communication. Space communication. Okay. Satellite launching, how the satellite is moving, and all we can. What is the place of the satellite? What are all the activities going on, and we can find through these super high frequencies. Next one, extreme high frequencies. That is 30 to 300 gigahertz. Same as this one, radar, microwave, as well as space communication. Radar communications are nothing but radio frequency and it's a ranging. Okay, radio detection and it's a ranging. Microwaves means this can be have capability very tiny waves. Okay, this can have capability to move in extreme vacuum also. The different microwave regions based designs and corresponding services of electromagnetic waves are shown in this above table. Okay. Now, band designs and frequencies. The standard band designs for microwave frequencies listed IEEE as shown in figure. I think everyone feels that these are boring, but we have to learn all those values, because unless and until if we won't learn all those values, we can't able to detect. These are mostly helped in our in communication department. Whenever you move in communication field, you have to learn about all those. Being an electronic students, we have to learn all those frequencies and their bands also. Okay, first UHF frequency that ranges from 0.3 to 3.0. Large frequencies 1.1 to 1.7 gigahertz. All those are in gigahertz. See, similarly here, S band, C band, X band, KU band, K band, KA band, Q band, U band, M band, E band, F band, G band, R band, some millimeters. Sub-millimeters are above greater than 330 gigahertz. Okay, the standard band designs of micro frequencies are listed based upon the IEEE format. Okay, IEEE has shown this table. Advantages of microwaves. There are some unique advantages of microwaves over lower frequencies. Increased bandwidth availability, improved directive properties, fading effect and reliability, power requirements, and transparency properties of microwaves. Transparency properties of microwaves. Increased bandwidth availability means if we know the particular frequency, if we know about particular frequencies, then the bandwidth availability we also know, because so many number of bands were increased. So it is a good thing for us. Improved directive properties. Okay, directive properties means ultra high frequencies they are using, microwaves they are using. So these can be improves properties of our works. Okay, fading effect and reliability. It cannot have a fading effects and the reliability is more. It means correct information we will get. Power requirements are very less. Transparency properties of microwaves. Next one, first of all, applications of microwaves. Now let us discuss about what are all the applications of microwaves. Microwaves have broad range of applications in modern technology. Now we are living in present modern technology, isn't it? They are most widely used in long distance communications, radar, navigations, radios. Our relatives are in foreign countries. We can able to communicate with them or not. All those can be used for long distance communications, radars, navigation. For where without knowing any address we can move by using Google Maps and all those are used with these microwaves. First one is telecommunication. Microwave frequencies are used in communication such as telephones, TV, space communication, earth to space and space to earth, telemetry communication links for railways, etc. Here, telecommunication means for us everyday broadcasting of TV programs such as telephones. We can make a call with any place at any time. Okay, space communication means whatever we are giving message from earth to space and from receives message from space to earth. This can be possible with these microwaves. Telemetry communication, that is linked for railways. Wherever the railway tracking of a train and all those happens with this communication. Next one is radar. Radar, main purpose of this radar is radio communication, detection and its ranging. Okay, radar detection and its ranging. Radar means direct detect aircrafts, track guide supersonic missiles, observe and track weather patterns, aid traffic control, bulgar alarms, garage door opens, police speed detectors, etc. First of all, direct aircrafts. To detect aircrafts, we can able to detect what are all the other our enemies. They are in military appliances for detecting aircrafts and all. For finding wherever the missing things and all we can find through these radars. Next one is track guide supersonic missiles. Okay, wherever the in military purpose some missiles they can be lit without unknowingly they can throw missiles. Okay, we can track that missiles also. Observe and track weather positions, weather patterns, air traffic control. Air traffic control means for aeroplanes and all so much of traffic control that can be controlled mainly with these radars. Okay, bulgar alarms, wherever the alarms which are present, nothing but whenever any unknown persons or any other, for example, vulgar alarms, they can have loud sounds that so that we can alert at any situation. Okay. Police speed detectors and all we can use these radars. How radars are useful in these commercial and industrial applications use a heat property of microwaves. Okay, commercial and industrial applications for heating, they use microwaves. Microwave oven, we know in every house there is a microwave oven, isn't it? We can use for cakes and all of the microwave ovens can be used. Dyeing machines, textiles, food, paper industries or dyeing clothes, potato chips, printed matter, etc. All those dyeing machines they can use all these applications. Food processing industries, pre-cooling, cooking, pasteurization, sterility, heat, frozen, refrigerate, pre-cold, maids, roasting of food grains, beans, food processing industries, they can use this type of microwaves. Rubber industry, plastic, chemicals, forest products industries. Mining, public works, breaking rocks, tunnels, boring, drying, breaking up concentrate, breaking up coal streams, carrying of cement. This can be used. Dyeing inks, dyeing sterling gains, sterling pharmaceutical, dyeing textiles, leather, tobacco, power transmissions, all those can be useful. Biomedical application. This is the main application for diagnosing therapy for diametry, determine for localized superficial heating, deep electromagnetic heating for treatment of cancer, chemotherapy treatment, isn't it? Everyone heard about this chemotherapy. This can be here they use mainly electromagnetic waves for this treatment. Okay, transmission through the electromagnetic transmissions through human body and use it for monitoring of heart, lungs, water detection, etc. Electronic warfare, ECM and ECCM, electronic countermeasure and electronic countermeasure systems, separate spread spectrum systems. Okay, identifying objects are personal by non-contact method. Okay, now this till now we all are learned about what we all are learned till now about introduction about microwaves. What are all the bands present in microwaves? as well as the frequencies in the power of 10, and symbols we learned what are all the regions of band designations by using ranges as per CCIR recommendations, and band designs, frequencies, applications. Here we also learned about applications of microwaves. Okay, thank you for your watching, my dear friends. If you have any doubts regarding this, please comment me on my comment section. Thank you.